Good afternoon, everyone. Welcome to Mastering Backend Community Office Hour. My name is Welcome Blessing. I'm the community manager for Mastering Backend. Welcome to today's Community Office Hour. We're excited to have you join us for this section focused on cutting AI costs by 70%. As a community, our goal is to provide a space where backend engineers and tech enthusiasts can learn, connect, and gain practical insights that can be applied in real-world scenario. So today's section is practically important as AI continues to grow. It's very critical for developers to just also know about these things. Today's section, we have a guest speaker and a very good one. His name is Mr. Obina Okafo joining us. He's already here on the call. He's an experienced backend engineer, known for building scalable and cost-efficient AI systems. We believe that you're going to gain a valuable insight from his sections today. So please stay engaged and feel free to drop your questions in the chat box because we're going to have a dedicated section for Q&A after the section. We are opportune to have Mr. Obina Okafo on this call. So it's my pleasure to introduce our guest speaker for today, Mr. Obina Okafo. Please, let's just use your favorite emoji for him. Thank you everyone. So over to Mr. Obina Okafo.
Hi. Good morning.
Hi.
Or rather, good afternoon.
Good
Thank you for the warm reception. I'm Okafo Obina Kensley. I'm a full stack software engineer by major on backend. I'm the head of engineer Recruiter Africa, and I've built a couple of products. So that's just me in the nutshell. So I'll be talking about cutting AI costs. Yeah, because we know in this day and age, there's nobody that will say, oh, they don't know about or they've not heard about AI. I'll soon be presenting my screen, but I'm just giving a brief introduction. Yeah. So artificial intelligence, AI, like we call it, or as is well known in the engineering space, LLMs, they help us automate. You understand? They help us with a lot of things that typically would have taken us, a lot of training for us to know. So that's the whole idea of AI. So let me share my screen now. All right, so how do we reduce, before we look at how to reduce AI usage costs and whatnot, let's know what LLMs are, because a lot of people have been hearing the term LLMs, they don't know what it is. So LLM simply means large language models. Before I continue, if you have questions, so you don't miss your train of thought, you can always jot it down. When we get to the question and answer session, you can always ask your question, you understand? So you don't lose your train of thoughts. So LLMs are large language models. They are deep neural networks trained on billions of text tokens to understand patterns, context, and generate human-like responses. So there's what they call multimodal capabilities. A lot of LLMs nowadays have multimodal capabilities, which goes past generating text down to generating images and other multimedia, that's videos, Excel sheets, problem solving, war plans. Like it scales fast just text generation nowadays. So those LLMs that have that ability, they have what they call multimodal capabilities. That's what multimodal capabilities is. They also have, there are some LLMs that have transformer architecture. So they understand how a particular system works and they can easily transform instructions to that particular system. So nowadays you see LLMs running on a couple of devices that you shouldn't run on, but because they already understand the instruction set of those devices, the LLM can actually communicate with those devices and control those devices. So emergent intelligence at scale, few-shot learning, chain of thought reasoning, and task generalization without explicit training. So the LLMs are getting smarter by the day because with more information, the whole idea of LLMs is data, basically. So the more data you feed an LLM, the more it can read patterns, the more it can understand patterns, and the more it can give curated responses. So how are LLMs trained? So we're talking about LLMs. We already know what LLMs are, which are large language models at this point. So there are billions of texts, that you give to a particular machine that it's used to understand human patterns and give curated responses, right? So how are they trained? So first of all, data collection, right? So they get data. That's why you see the big boys in AI space, Google, OpenAI, Anthropic. How do they train the models they train? They get this data and they have what they call data companies. These companies, what they do is to sell data, and they sell data to these AI companies for them to be able to train their models. So one of the people that has been, that have access to our data, we all know Google. Any small issue you have in those days, before the emergence of AI or LLMs, we run to Google and research. So Google already has billions, if not trillions, of human patterns, the kind of questions that human asks, and how to respond to those sort of questions. So that's all captured in data collection. So they get massive data sets. This data set is not limited to text. It can be anything, videos, text, mathematics formulas, whatever it is that as a human being, you can actually train an AI on it, right? So they collect this data, and there's what they call pre-training, whereby, okay, you pass this data into the AI and then you generally modify the AI with those data. So you pre-train supervised learning to predict next tokens using transformer architecture. All these are, except you want to become an ML engineer, that's a machine learning engineer. This is not your field, you understand. Then you fine tune the data, get human feedback. You see most of the time when all these big AI organizations wants to release a particular model, they first of all have a curated test user group that will test the model, give feedback before you see them publish it, right? And then when they are done, they deploy the model, right? The deployment doesn't mean that the training of that model has ended, right? They keep on getting feedback, they keep on getting recommendations and ways to fine-tune the model, and next thing they bring up a new or a better model. The most popular ChatGPT that we all use, it started with Mini, and now we have GPT-5, or we even have more advanced models that they've released so far. You understand? So, like I explained, these AI companies have, we've seen how the LLMs come about, right? Now, different LLMs have what they call different size. And when you train a particular LLM to a particular point and you publish it, it's called a model, right? And different model has different size. And this size depends on the training data. Like we already know, for you to get an LLM, you have to train it with billions, if not trillions of data sets, right? So we need to understand what some of these weights and sizes of models are. So when you see things like 7B model, it means it was trained with 7 billion data sets. That's what it means, right? When you see something like 13 to 70 billion, it means it's within 13 to 70 billion data sets, you understand? So they have different models, like the more powerful models nowadays, you see them trained with trillions of data sets, right? So the more capabilities you give or you train a large language model, it simply means what that translates to is that you're feeding it more data. Basically, that's what it means. Because you cannot tell me that a 7B model has more capabilities than a 70B model, except the 70B model was trained with a specific data set. I don't know if you understand. Let's say I train a 7B model with code, how to write JavaScript code, for instance, and I train a 70B model on how to still write JavaScript code. You can't tell me that 7B model will even come close to the capabilities of what the 70B model can do when it comes to writing code. Does that make any sense? And so you see these AI companies, they attach prices to this model, because for you to run a model, basically, you can run a model on your system if you have a very powerful computer. So do not look at it as, oh, okay, it's only for the big boys and whatnot. If you have a powerful computer as small as a Mac Mini, or your computer has a very good GPU, because AI models, because of how large the data set is trained on, is going to clog your CPU if you try to run it on your CPU. Although there are models nowadays that can run on CPU, but on high-end computers, you understand? So imagine running 7 billion. What's the size of RAM that you have in your system? It's just going to clog your system, and your system will feel super slow. So there's no point running these kind of models on your system, except you have a very good GPU that is very powerful. You understand? So you can run these models on your system. The whole idea of these AI companies, what they do is, first of all, they hoard their very large models, because obviously they want control. Imagine them making it open source, and then people have access to those billions of data set trained models. They're not going to make money, because they spent money training and fine-tuning these models and these LLMs. So they need to obviously make the money back. And how do they make the money back? Users that come to use it. So nowadays, people use OpenAI, ChatGPT models. They have Claude. That's a product of Anthropic. They also have Claude Code. There are different models. They have Microsoft Copilot, although we know in the background they still use OpenAI models. There's DeepSeek. These are different AI companies and their models that they've released so far. So for you to use each of these models, although most of these companies have open sourced some of their models, but obviously not the most powerful models. They've open sourced, like for instance, DeepSeek has open sourced their DeepSeek 4. So if you have a very powerful system with a good GPU, you can actually run it and use it locally, right? That's the whole idea. LLM cost crisis, monthly enterprise cost range from $120 for small apps to $4,000 for large production applications. We already discussed the whole idea of all these AI companies and how they make money. Obviously, they are powerful models. They're not going to open source it. So it's closed source, it's proprietary. And the only way you can access it is probably you subscribe, or they give you a throttled access, whereby, or a rate limited access, whereby you can use it up to a particular point, and then they ask you to pay, or you wait for the rate limit to clear before you can continue using it, right? So ChatGPT, for instance, I'm sure most of you have tried using ChatGPT, and you get to a point where it tells you that it has moved you to a lower model, or you cannot use it until you subscribe or something. So that's how these companies make money. But when it comes to using the models as a backend engineer or as a DevOps engineer, you need to communicate with these AI models via API, right? So, and each of these API calls is priced. So they give you a particular context limit, they give you a particular limit that you can use, and they attach a price to it, right? And then when you're calling these per call, there's what they call input tokens and output tokens. We'll explain that here. So input tokens is basically you are giving the AI an instruction, you're asking the AI what to do. All that is input token. It costs input tokens basically, right? And when the AI responds, those responses as well are cost output tokens. Do you understand? So basically, output tokens cost 4 to 5 times more than input tokens across major providers, dramatically impacting generation-heavy workload. Enterprise LLMs spend 300 to 500% annual growth as application scale and usage pattern mature. Provider prices vary significantly. GPT-4, this is our OpenAI models, cost $2.5 as compared to $10 for Claude Opus. So GPT-4 costs $2.5 as compared to $10 for Claude Opus. Claude Opus is a product of, or is a model of Anthropic, right? At $5 or $25 per million token, right? So understanding token economics, token to word conversion. Now, AI doesn't understand the way you type words. It's not how AI translates it to token. So basically, one token is approximately 0.75 words. So what that means is 100 token equals to approximately 75 word of text. Does that make sense? So when you write different words, it's not just translated to token, it's approximately 0.75 words. There is a particular metrics that the AI uses in calculating token, and it's standardized across board. So input versus output pricing, output token costs 4 to 5 times, like I already said, that input tokens across major LLM providers. Real world calculation, the 500 word article equals approximately 670 tokens for processing. So what that means is that every single time that you communicate to an AI, when you send it an instruction set or you ask it whatever you ask it, it converts it into token and it charges you for the input token, right? And now when the AI is responding to you, for each of those responses, it calculates the number of token and it also charges you for the output token. Does it make sense? So, for example, we have the GPT 4.0 processing cost, which costs about 0.00611675 per standard calculation operation. So strategy, 5 core approaches. This approach now is how we can cut costs across board. So 5 core approach in optimizing costs. Number 1, we have the intelligent model routing. Now, what do we mean by intelligent model routing? We have frontier models, like I said, using the latest AI models. Obviously, it gives you more capabilities and it gives you more results because it's trained with more data sets, right? But the problem now is for you to run an AI that is trained with 1 trillion tokens, you need a very powerful computer, right? And these AI providers, obviously, they have these computers, and what they're basically doing is they're going to charge you more for using a more powerful token, a more powerful model. Sorry, you understand? So for very simple text processing or request, you don't need to use the very powerful models like the latest frontier models like Claude Opus, or you're trying to use GPT-5 for something as simple as call a tool, or something as simple as summarize this text and give me key points. Like, there are lower models that can do that comfortably, and you don't have to spend more, right? So as a backend engineer, you need to first of all understand the model to use for different tasks. And it's not in every case that, because let's say you're building a chat completion system like the normal ChatGPT that we know, where you go and ask it questions and it answers you. It's not, you don't know how your users are going to ask questions or the kind of questions they're going to ask. So you can use very small models that are trained specifically for this task. So basically, what does this model do? It gets your input, that's the input that the user imputed, and then it looks at it and say, oh, okay, a small model like GPT 4.0 mini can handle something like this, or GPT 3.5 mini can comfortably handle something like this, and then it routes the request to that particular model, right? Or if you can easily tell, or if you can tell the kind of questions that your users are going to ask, then you can manually do that. You don't have to use an intermediate model to make that decision. Does it make sense? So you route requests to optimal models based on complexity, achieving significant cost while maintaining performance quality. Task completion assessment. Analyze request complexity to determine appropriate model tier for optimal cost performance balance. We already said this. You can do this automatically, or you can do this with a very small model. So there are models trained specifically for this. They get your input, and then you can easily tell the model that has the capability to give you good response without hallucinating. And we'll talk about hallucinating in a while. Model selection criteria, around 70% of requests to cheaper models like GPT-4 mini versus GPT 4.0. So you can see the cost here. Now, you might be seeing this kind of cost in AI, this sort of cost where you see 0.4/1.60. Now, normally it is cost per million token. Now, 0.40 means it will charge you $0.40 per million input token. Please take notes. then slash 1.60 means it will charge you $1.60 per million output token. Does it make sense now? So for GPT-4, it charges you $0.40 dollars per million input token and $1.60 dollars per million output token versus GPT 4.0 that charges you ridiculous $2.5 per million input token and $10 per million output token, right? So you can see that you're already saving huge amount of cost by using GPT-4 mini, because rather than, but some people in this day and age, they just go because they hear, oh, OpenAI has released GPT-5. You want to run and now use GPT-5, not knowing that you're going to spend, a premium for using it. So cascade routing implementation, start with small model, escalate only when needed. SETA framework achieves this efficiently. Performance versus cost trade-offs, achieve 50% cost reduction with 80% latency improvement through intelligent routing. Now we already talked about this intelligent routing, where an AI model or a very small AI model is already trained for this. You give it an input, or it takes your input, and then it can easily tell the model that has the capability to handle or give you proper responses. Now, routing implementation patterns, two distinct approaches to intelligent model selection with different trade-offs. Now, we have the pre-generation routing and we have the cascade routing. Let's talk about pre-generation routing. It analyzes request complexity before model selection, right? Lower latency with single model call per request, achieves 20 to 30% cost savings through smart routing, requires upfront complexity analysis implementation, and best for predictable workload with clear patterns. Now, cascade routing starts with cheaper model, escalates only when needed. Higher latency due to potential multiple calls, superior 40 to 60% cost saving through adaptive routing, built-in fallback mechanism for quality assurance, ideal for unpredictable or mixed complexity workload. Now, what do we understand by these two? This first one, a model sits in between, a very small model, it takes the workload, and then it says, oh, GPT-5 is ideal for this sort of workload, or GPT-4, or GPT 3.5 mini, or GPT-4o, or Cloud Opus, or DeepSeek is best trained for this sort of problem, right? So use that particular model as compared to cascade routing, where from the get-go, you just start with a very small model. And now, when you start with a small model, the problem with cascade routing is when it gives you a response, you now need to analyze. So basically, you give the AI an instruction, more or less like, okay, a system prompt, like, okay, when you get this user response, and when you respond, also respond with how accurate you feel your response is. Now, the AI is going to give you a response, and as well, it's still going to respond with how accurate it feels its response is. Now, based on that accuracy, you cannot tell, oh no, it didn't give me high accuracy, like more than 70 or 80%. So what that means is that the AI was not trained with much data sets to give me more accurate answers. So you need to use a more powerful model to get a more accurate response. You understand? So based on that, now you can now reroute that same request to a more powerful model, and to now give you a more accurate response. Does that make any sense? So that's the whole idea and difference between pre-generation routing and cascade routing. Let's continue. Strategy 2, multi-layer caching. Now, this is very important because we need to cache repeated AI responses. If not, we are just going to be spending money for something that we already have the result of. Let's say we are building a system for ChatGPT whereby people normally ask the same kind of problem based on trend, or let's say during the time that the whole Iran-US war started, and people want to know what's going on, so they're asking, what initiated the war between Iran and US. Now, this AI model can go as far as searching the web because it has capabilities, tools I can call, do complex logic to try and get what's going on between the US and Iran. Now, imagine it does that same number of steps, like searching the web, processing the data it got from the web, analyzing it, and then creating the reports for every single request Now they'll be running at a loss because for you to do all that, you're spending billions. Now we think these AI companies don't really spend money. They spend money. They spend money on electricity. They spend money on maintenance staff. They spend money on maintaining the model, training this model. So they spend billions of dollars, right, doing all that. So imagine they are making this request for every time somebody makes that same kind of request, is going through the steps of searching the web, creating a report and whatnot for that same kind of data. They'll be spending much money. So what it does is, after it does that, it cache the response, save it somewhere. Now, when somebody makes a similar kind of request, it already has the response before, right? So you can just give them that same kind of response in a different English. But it's not going through the process of, okay, it's now going to search the web, create a report, trying to understand what actually caused the war or whatnot. Now, this cache can be done in different layers and levels. You can do a cache on your end, you can do it on the model provider end. So there's exact match caching where you cache identical queries with 90 to 95% hit rate for repeated requests, eliminating redundant API calls. So what that means is that if you are building a sort of system where you know your users will ask the same kind of questions, or for instance, you have an AI capability on your system whereby to analyze documents. You already know the steps that it's going to take to analyze the document. So if it's going to analyze a document that it has analyzed before, you don't have to pass it to the LLM. You can just cache the results somewhere for that particular document. When next somebody comes with that same document and be like, analyze it, you just give the person the response. No need to call the AI model or anything, you understand? So this is already saving us massive amount of money, right? Semantic similarity caching, so vector-based caching for similar queries, achieving 60 to 80% rates. So the question, let's still use the same analogy of Iran-US war question, right, to the AI model. Now, however, somebody might ask a question, the AI model understands that this person wants to know what's going on between US and Iran. Now, the person might come with, oh, what's going on between US and Iran? Or what started the war between US and Iran? All these are similar questions. So they are very similar queries. So you can easily cache this sort of queries and then give the same kind of response, right? Now there's prompt/context caching, cache repeated context and system prompts for 95% savings or repeated context processing. So when you have the same context that you've processed before, you can just cache the response. So next time that somebody is making that same kind of request, you don't have to hit the model, but thereby spending tokens, you can just give them the response upfront. Now there's what they call cache invalidation strategies. Now, using the same analogy of Iran-US war, the AI might have searched the web yesterday, and probably there's some new information that happened today, right? You need to be able to tell that, okay, this information that you currently have cached is stale, is old. That's what it means. So you need to get the updated information. So you invalidate that stale cache, you understand, and get new information. Combined impact, multi-layer caching strategies achieve 50 to 70% total cost reduction when implemented together across your LLM infrastructure. Caching architecture and implementation, exact match caching delivers 95% hit rate using Redis Memcache. So as backend engineers, I believe you already know what Redis and Memcache are. They are in-memory cache systems, key value cache system where you save a key with a value in memory. And the whole idea of having it in memory is, like we know from our elementary computer days, accessing data in the RAM is way faster than, millions of times faster than accessing data on the ticks. You understand? So because the RAM is, we already know, random access memory, the ROM is, it has different blocks where it stays its data. So it will have to go through the stress of looking for the different blocks that houses the data, getting all the blocks, getting the data, ensuring that data integrity is okay, and before it will deliver that to you. All this happen on the line. You don't even know that it's happening. You understand? So we have semantic caching, which achieves 75% hit rate through vector database. like Pinecone and Weaviate for similar query matching. We already discussed what this is, like the different ways, but you already know that, okay, they are trying to ask the same question, right? So they call it vector query search, right? Then there's the prompt caching. So the prompt caching is the exact prompts. You cache the exact prompts that was sent to the AI model with the exact response. So it provides 90% hit rate using provider native solution like OpenAI, Anthropic for context reuse. And there's a combined multi-layer approach typically delivers or achieves 50 to 70% total cost reduction with proper cache invalidation strategies. So strategy 3, prompt and token optimization. Now this is very, very important. Most of the time we copy a full document or we pass or we upload a full document to these AI models and we tell it to give you, you ask it questions based on this document and whatnot. Now, remember our input and output token that we discussed when we started this whole discussion. The more words that are in your document simply means you're going to spend more input tokens. And the more response you are trying to get out of the AI, it simply means you're going to spend more output tokens. So there are a couple of models that can take in like lightweight models, and we already know that lightweight models cost way less. They can take in this your full text that you're sending to it, and it will optimize the request that you're trying to get before it will now pass it to the actual model that you needed to pass it to, right? These models were built for cost saving, right? So it takes your full text, optimizes it. What optimize means is it changes the grammar and make it brief. So before, if you're writing a 100-page article about what you want the AI to do, you can reduce it to 10-page or 5-page without losing performance or actual intent. You understand? So reduce token usage through compression techniques and efficient prompt engineering, achieving average prompt length reduction from 1,000 to 300 or to 500 tokens. Prompt compression techniques, advanced compression methods reduce token count by 30 to 50% while maintaining semantic meaning and context. I already said that. Context window optimization. Now, there's something called context window. You must have been hearing it in most of this AI where you say, okay, it has a context window of 250,000 tokens. So what that means is that in a single session, the AI can only take 250,000 tokens. Does it make sense now? So what that means is that, okay, you give the AI a request, it gives you a response, you ask it to fine-tune its response based on more parameters, it tries to fine-tune the response. So each of these input outputs that's back and forth creates the context window. So both the input and the output, because we are now making a subsequent request, it needs to pass in all these previous requests to the AI model. So it understands that, okay, this was what you said, this was what I responded, this was what you said, this is what I responded. Now you're asking me to do this. So it can easily infer and tell that, okay, based on this response and that response, you are not satisfied. So you want me to respond this way. So you're using platforms like ChatGPT, where you have back and forth with the AI model. It gets to a point whereby you cannot continue asking questions. By that point, you've gotten to the limit on the context window, right? So that's what context window is all about. So you eliminate redundant information, optimize context structures to maximize efficiency within token limits. Token pruning strategy, strategic token removal achieves 50 to 25% reduction on minimal impact on output quality. So while in the context window, you don't have to send every back and forth. There are some that has zero meanings or that is going to affect the outcome in no way. So you just take it off. You understand? You don't have to send everything back because remember, your mind should always be on input token, output token. That is where your mind should be focused on to optimize cost. You understand? So if you can limit what you're giving the AI and if you can limit the number of responses the AI is giving you, but it's just giving you the specific response you want it to give you, then you're saving costs. Does it make sense? Quality versus efficiency, balance, optimize the trade-off between cost saving and output quality through systematic testing and refinement. So obviously, if as a backend engineer, you need to obviously monitor how your AI implementation is being used, the kind of questions that is being asked, so you can easily optimize and know, oh, okay, probably this model I'm even using is too big for the sort of questions I'm getting. I can use something smaller, or these sort of questions I'm getting, I can fine tune it in such a way that I don't have to spend more. You understand? So you have to monitor all that. So token optimization technique, template-based prompting, standardized prompt structures that eliminate redundant instruction and optimize token usage through reusable templates. So you can have a template that your users have to follow when they're making requests. That's one way to optimize costs. Context compression, advanced algorithms that compress conversation history and context while preserving semantic meaning and relevance. Now, there are a couple of AI models that do this, and all these are lightweight AI models, so you're not even spending at all, technically. Yeah, so they compress your context without losing your intent in the very first place. Like, we already know what context is at this point, without losing your intent, right? Because remember, if you are going to be sending the full back and forth to the AI model, you're spending input token, and we don't want that, right? Dynamic content loading, smart loading strategies that fetch only necessary content and data based on request patterns and user intent. Now, what this means is that you don't just tell the AI to respond to everything, that even the things that you don't need response to. You be specific what you want it to respond to, because remember, output tokens are very expensive. So if you are not going to prompt very well your AI and you allow it to just give you useless outputs, you're spending money. And is heavy money is way, way, way more expensive than input token, remember. So you need to be specific with your prompts when you're asking the AI to do anything, so you know specifically the sort of response you want. There are other ways, like there are standardized way, JSON output schema that a couple of models support today, where you tell it, so you give it a schema that you want your data to, how the response should be like, and the AI model will respond in that exact same schema. So it removes all this complexity for plenty words that doesn't have any meaning. You understand? Attention-based pruning, machine learning techniques that identify and remove low importance tokens while maintaining model performance quality. We already discussed this. AI models that helps do all this. Strategy 4, efficient serving and inference. Like I said, you yourself can host an AI model locally on your system. And if you are using different cloud provider, let's say you have a system where you have millions of users, and you know these users actively try to ask some sort of questions, text processing. All this can be handled by very small models. So rather than paying OpenAI or Anthropic to be answering all these small, small questions, you can actually host this AI model yourself. It's cheaper. All you're just paying is the hosting fee, right? You're paying the hosting fee, and now all the requests will be processed through your self-hosted models. Rather than, you notice your millions of users are asking, text processing questions, like it's not even complex. And you're passing everything to ChatGPT, and obviously ChatGPT, they need to make money. So you're just going to be spending millions of dollars every month when you can comfortably host your own model with like $10,000 per month, as compared to dashing OpenAI millions of dollars in normal text processing. So that's why you see the likes of Microsoft nowadays, they have their own models that they use. Initially, when Microsoft started, we all know that they were using OpenAI models. Before they now had to build their own models, because obviously Microsoft is very big. There's nobody that has a Windows laptop today that will say he has not used Microsoft products. It's impossible. Outside Windows, Linux users, they also use Microsoft products on the web. You understand? So Microsoft is very, very big. So it will just be them spending billions of dollars to open AI when they can have their own models that can handle these requests themselves. So self-hosted deployments and cloud APIs. Break even at 50 million token per month for cost efficiency. This is even too much, sincerely. GPU costs $0.5 to $5 per hour, depending on model size. Full control over data privacy and model customization. Now, because you are hosting your own model, you have full control. Like, you're not dashing. Remember, like I said earlier, all these models are built based on billions of data. So you using ChatGPT or Claude or Grok or whichever AI model you're using, yeah, as well giving them something very valuable, which is what? Data, right? Because imagine you ask the AI a question and the AI responds, and then you're satisfied with the response. Now they've gotten training data because now they've gotten, oh, for this question, this answer seems satisfactory. They've gotten free data. But if you have control over that, you have control over your proprietary data. It's not being used by third party to fine tune their models or the next iteration model that they're going to release. You understand? So you have full control over your data, and model customization requires infrastructure management and DevOps expertise. So for this, you need like a DevOps engineer that is going to help you with that. Except if you're very good with setting up systems, then you can always run it yourself. But with the likes of Docker, all you just need is just few hours and you're up and running. Because Docker already has an AI implementation that you can use in launching AI models out of the box. So you don't have to even stress yourself going to learn the schematics of the different AI model and how to host it. You understand? There are other utilities like Hugging Face that can help you with hosting your model and whatnot. Now, cloud APIs, we already know cloud APIs, the likes of ChatGPT, that's OpenAI, Anthropic, Claude, and all the AI models that they have. So for you to access these third-party AI models, like I said earlier, you need to communicate with it via an API. So the pricing, they're charging you $0.1 to $30 per million token with pay-per-use model. Very, if you've been building a backend system that has AI integration, or you've used third-party AI integration, definitely you know there's pay-per-use model. Instant scaling with zero infrastructure management. So you don't have to care about the infrastructure because they're already hosting it for you. All you have to do is just make a request. You're paying per use, you're using it. So you don't have to care about hosting it and ensuring that it's running. Manage infrastructure with high availability. Now, these guys, one thing they pride themselves in is ability to respond to millions of users per second, right? And that is not easy. It requires huge hardware running these models for them to be able to deliver that sort of latency. You understand? Immediate deployment with no setup time required. Now, the cloud provider is already running. You don't need to care about deploying it or not deploying it, you understand? Now, there's something they call hybrid strategy. Deploying 75 to 80% self-hosted with 20 to 25% API fallback for peak loads and specialized models. Now, like we said earlier, you can have a small model that you hosted locally that can easily make the decision that, oh, okay, for this request, our self-hosted model can handle it. But for more specialized or complex requests, it can now pass it to the third-party AI models like GPT-5 or Claude Opus, you understand, for them to give the response. So it's left for you. The hybrid strategy is obviously going to save you way more. That's if you're having millions of users using your AI infrastructure, you get. So specialized model batch processing reduces cost by 50% for non-real-time tasks. So this is a batch processing optimization, dynamic batching strategy, automatically group requests for 30 to 40% throughput improve without sacrificing latency. Now, if you're using a third party, you need to like OpenAI, and you're having millions of requests. Most of these platforms, they charge you per request. and they give you a rate limit in terms of how many times you can access their API per second or something. So one of the ways to leverage that is to batch requests. So you send multiple requests at once to the third party so that they can respond. Now, all these multiple requests is just going to account for one request. It's not going to account for, oh, you sent 10 requests, for instance. It's not going to account for, oh, you called their API 10 times. It's going to account for you just call the API once. Now you're seeing the benefit already because now you have more, you're not overusing your rate limit, right? Continuous batching benefit enables ongoing request processing with 50 to 60% efficiency gain over traditional batching. Chunk prefill optimization reduces initial processing latency by 25 to 35% through intelligent token chunking. Now, what does this mean? You see, most of the time when you send OpenAI requests, immediately it will start responding to you. And as it's responding line by line, it's not waiting to get the full response before it answers you. Now, this will help in terms of, okay, your user will feel like, okay, this answered me immediately. I don't have to wait for the whole thing. It's taking seconds. Now, it might take about 5 or 6 seconds for it to fully answer you, but because it's streaming, you don't feel it. Because you're seeing it line by line appear on your screen. You don't feel like, oh, this is taking time to answer me. You understand? That's the whole idea behind this. Batch API discounts offer 50% cost saving with Open API, Batch API for non-real-time workloads. Implementation notes, modern framework like LLM and SGLang provide built-in support for these advanced batching techniques that you're using platforms like Python. Strategy 5, which is the final strategy, monitoring, FinOps, and architecture management. Obviously, like I said, if you're building an AI system, you need to observe the kind of usage, you need to see the kind of questions that is being asked, and then you can now tell, oh, okay, I was using GPT-4, let me go down to something smaller because they're not asking something complex. Or you can put a small model in between that does all these checks for you. And you need to check the token usage. You need to set rate limits for your users as well because you just don't want somebody abusing your AI model. Remember that for every input, output, you're spending tokens. So you need to ensure and monitor that, okay, this is not abused and whatnot. So real-time cost monitoring with anomaly detection delivers 15 to 25% cost saving through early identification of usage spikes and optimization opportunities. FinOps as financial optimizations tools integrates using Vantage for AI native tracking, AI for unit economics, and cloud health for implementation guides. Microservices architecture patterns enable 20 to 40% cost reduction through service isolation and independent scaling optimization. Now, what does this mean? If you are hosting your model yourself, you can easily use platforms like Kubernetes. Like I said, Docker is a containerization platform, so it already has built-in AI abilities to run AI models. And obviously, we know Kubernetes is an orchestration system that orchestrates containers. So once there's high load, you can set it up to spin up more containers, and then it's going to share the request across different containers, right? Which means faster response. So if you're using microservice, which is containerizing your application and using services like Kubernetes or other orchestration like Docker Swarm to run your container, it can easily sense this increase or this spike, and it will provision more resources or more containers that is going to respond to this request. Then when the spike go down, it will kill those containers and leave 1 or 2 containers running. You understand? Governance and budgeting framework establish cost control, spending alerts, and automated resource management policies across the development team. What this means is you need to set a lot of telemetry so you get usage reports, cost reports. You need to know as things are happening, you're proactive because most of these AI platforms will not tell you. It's month end, they'll just swipe your card with about $10,000 or $15,000, and you'll be surprised. You'll be like, what did I do that costed me that these people had to charge me $15,000? You understand? So you just have to be proactive, set a lot of monitoring and telemetry alerts to see as it's happening real time so you can optimize immediately. You don't have to wait until they swipe your card with the money, then you start optimizing. You understand? So that's that. Architecture patterns for cost optimization. We already said microservice isolation, separated LLM service by functions, optimize model selection and reduce costs, reduce cross-service token usage through target routing. We've already discussed this. Zero token operation, eliminate unnecessary API calls through smart preprocessing, local validation, and cache decision trees. We've discussed this. Event-driven architecture, replace continuous polling with event-triggered LLM calls, reducing background processing overhead. We've discussed this, whereby you're calling an API every now and then, as compared to, it just gives you the response. Like whenever the response is ready, it calls you instead, rather than pulling and then you're wasting your rate limit. Or you're spending, because most of these platforms, they also charge you per API call, you understand? So you just need to be very careful with that. Circuit breaker patterns prevent cascading failures and cost spike by implementing intelligent fallback and rate limiting mechanisms. We've discussed this as well. Additional cost reduction strategy, model quantization benefits, reduce model precision to achieve 30 to 50% inference cost reduction while maintaining acceptable accuracy for most production use cases. We've discussed this, like rather than using ChatGPT 5, you can use GPT 3.5 to answer something as small as analyze this document and summarize it for me. You understand? Because you're just going to be spending more if you're using the high-end models. Like we said, those high-end models are trained on more data, and for a thing to be trained on more data, it means it needs more powerful hardware to be able to run it. And the AI provider definitely are going to charge you more for using it. Doesn't make sense. So edge deployment strategy, deploy lightweight models locally. We've discussed this, eliminate API calls for simple tasks like classification and basic text processing. Provider cost arbitrage, switch to cost-effective alternative like DeepSeek 4 at 0.30 million per input token versus GPT-4o at $2.5 per million tokens for suitable workload. Fine-tuning for efficiency, train specialized models to reduce prompt complexity and token usage while improving task-specific performance. What that means is you can either train, if you have the capability to train. If you don't have the capability to train, look for lightweight models that are open source that you can deploy yourself and use if you're having a lot of use case for that. Let's say you're building an image processing platform whereby users can upload their image and send prompts for it to automatically adjust the image and whatnot. You're not gonna start using something like GPT-5 that wasn't trained specifically for image. You look for a particular image model, probably that is open source. That's if you have millions of requests for that, then you host it yourself. Or if you don't have millions of requests, you can use a third party, but that is specifically trained for image processing. You understand? Don't get me wrong, GPT-5 has some sort of training regarding image, but it's not core image processing. There are other models that all they trained this model on was image processing. Does it make sense? So that's that. Real world case study, 60% cost reduction. Context caching delivered, we've already discussed this, 95% saving on repetitive operations, dramatically reducing token consumption across all workflow. Model routing from Opus to Sonnet. Now, these are Claude Anthropic flagship models. There's Opus and there's Sonnet, right? So Opus is the latest model as of now. The Sonnet was the one before Opus. So model routing from Opus to Sonnet for 80% of the tasks maintained quality while cutting costs significantly. The problem is when people hear, oh, these people, Anthropic has released a new model, or OpenAI has released a new model, they'll run and start using it. It's not supposed to be so. Like you're just spending money. If you know something, an older model that is saving you cost is doing exactly what you want it to do, don't stress yourself. and say you want to start using something more powerful because you're just going to be spending money. Zero token operations, and whereas GPT-5 is one of the worst models in today, day and age. I don't know of the new variants that they've released so far, but the first iteration of GPT-5 was so useless. Zero token operation optimization eliminate unnecessary API calls. We already discussed this, like caching and whatnot. Total monthly savings of $72 achieved through strategic implementation of all optimization techniques. Now, we already know this is a backend, your main session. This was what it was before. This is what it is now. Before you're spending $120 in your main session, now you're spending 48. Cron jobs as well. Cron jobs are background jobs that run in the background. Some agents. You can create different agents based on models. I believe we already know what agents are. Agents are it's an AI categorization that basically focus on a particular task. So you can give it tools, you can give it skills, you can give it whatnot. But the core of this particular agent use models, don't get me wrong. But the core of this particular agent is to perform. So there's different agents, coding agents, report generating agents, like different agents, you understand? The most used in the world today is, as engineers, we are on the cloud code. That's a coding agent, you understand? It uses Sonnet in the background, although for high-end cases, it uses Opus. It's Anthropic products. So key takeaways, we start with caching, implement context caching first for highest ROI and immediate cost reduction impact. Intelligent routing, we discussed this. Deploying model routing for immediate 20 to 40% by matching tasks to optimal model. Monitor continuously, very important, because you don't want at the month end when they've debited you, you start complaining. So you can optimize costs as it's happening immediately. So if you notice that using GPT-4 is very expensive and it's not something that is attainable, you can quickly switch to DeepSeek V4. You understand? Or you can switch to Claude. Claude are very expensive models, but they give good results, but they're very, very expensive. Batch processing, so you leverage sending multiple requests at once to third-party AI services. Then hybrid deployment, we discussed this, whereby you can host lightweight models for text processing and whatnot on your end, and use third-party models for complex tasks. You understand? So now we've gotten to QA. Okay, you can go on.
Okay, you can speak.
All right, thank you. You spoke about catching, understand. Using catching when in my project, let's say I use catching, that means users requests will first check my catch before it hits the LLM. And if I have a meaning in my catch that is similar, that's the response that my user will get. So what exactly do I catch so that when my user make request or ask some question, he will get a meaningful response via the catch than reaching the LLM? Because when it goes to the catch, it will still check the similarity with that response.
So it depends on what you're actually building, right? So it's based on what you're actually building. So for instance, if you're building a system like images modification, whereby they've uploaded an image, or you're building a system for passing documents like PDF. Now, when the model has passed that PDF, and you know that, okay, multiple users might send this kind of PDF for passing, you can cache the past results of that particular PDF you sent to the LLM for it to extract information. So rather than repeatedly for that same PDF, you're sending it multiple times to the LLM, thereby spending tokens, you can always just cache the response. Now, next time you're sending a PDF, you can compare byte by byte. Is this the exact same file? If yes, use the results. No need to hit the LLM anymore. You understand? There are other strategies of caching, like you can cache the actual context that was passed in. So let's say you're building a system whereby they just, let's say job application, for instance, and you're trying to see, oh, okay, does this person match this particular job, for instance? Rather than every single time hitting the LLM, passing the user profile and the job profile to the LLM to try and compare that if this user is a good fit, you can cache the user on your system versus the job on your system as compared to the response that you already got. So next time you come and you want to compare that same user, you already have this result to this job. You don't have to hit the LLM again, you understand? So it depends on what you're building. You just have to look at it and ask yourself, there are some things that cannot be cached because it doesn't make sense caching those things, right? For instance, if you don't know, like for instance, ChatGPT, you can barely cache except it's similar vector-based caching, whereby you're trying to see, okay, this person asked me about the war happening between US and Iran, and that person is asking me something similar to the war. Now, you can easily use vector-based caching and say, oh, this question is similar, so let me give this person this response. You understand? So it just depends on what you're building. Does that answer your question?
Great, I appreciate it. So just based on like preference of the caching, not like working it like generally for each and every one of the platform.
No, it's not every application that caching is applicable, because caching, you only need to look at it. It's based on your architecture, and two, what are you trying to solve? Then you now look at, okay, is there a way that data can be cached in this regard? So it's based on specific use case that you can tell the strategy or the caching strategy to use.
Thank you. So his question was actually one of my questions. But one I want to ask about is you mentioned at the beginning that one of the strategies to save cost is to use different models for different sorts of tasks.
Yes.
And what I'm wondering now is like, say you have a system and you have like you're doing several things on the system. You are generating text content, maybe you're generating images. How exactly would you route this? I'm talking about, are you using like an agentic approach, or is there a different strategy when you're using just LLMs? How exactly would you route everything?
Now it's easier. You can use an agentic approach whereby, yeah, you have an agent, and then for every single request, like we said earlier, it goes through a trained model that has an idea of other models. You can have other models as tools in your agents, right? There are different ways to configure this, but the main thing is now you have a small model that every request hits through your agent. And this small model determines, oh, okay, who should I route this to? You understand? The small model can easily tell, okay, this one is the most capable, or this is not the most capable. It depends on your use case. Like for instance, if you're building a platform, like I said, that has to do with image processing, it doesn't make sense they are going to use GPT-5 for it. They are just going to be wasting money unnecessarily. There are other lightweight, good image models out there that you just have to do your research, check, usage, use it yourself, check feedback. So all these things are the iterations we're talking about. You just don't use the model, and because you heard GPT-5 is the latest flagship OpenAI model, you feel is the most capable. In that regard, they might not be the most capable. You understand? When it comes to financial reporting, there are other models that are great than GPT models. You understand? So you can just look for the appropriate model. It can be self-hosted, it can be third party. It's left to you. But the main thing is you look for the particular model that the data set that it was trained on is specific to your use case. You understand? So that's just it. And yeah, regarding choosing the particular model to use, like I said, you can do your research, have these different model options, probably as tools in your agent, or have it configured using an agentic workflow, whereby one model gets the response, and then based on how effective that particular model was in processing it, you can now tell the model to route it to. Does that answer your question?
Yes, it does. Yes, it does. Yeah, that's okay. Thank you.
Okay. Good afternoon, everyone. Thank you, my namesake, for for the breakdown and everything. So, based on your the last question that you just answered now, um, is the agentic workflow. Let's say I have a chatbot, for instance, that I want to implement this strategy on, and I'm using the agentic flow whereby this agent does this, this agent. Would the request timeout not be triggered within this period of this one calling this endpoint to check, come back, then call this tool or this agent to get the response and then push it back? So I'm looking at the time that it takes to conclude this and return back to the user. Won't it time out within that request? Maybe you are building a chatbot, for instance.
Yeah, if you're building a chatbot, you are going to build it in a streaming capability. So you're going to build it for it to have streaming capability. It doesn't make sense that you're building a chatbot without streaming capability. Now, what do I mean by that? Whereby you make a request and you wait. The user has to wait for the AI to be called, get the full response before responding. That's terrible. A lot of these AI models have streaming capability built into them. OpenAI, GPT, Claude, they all have streaming capability embedded in them. So yeah, you can go through, like we discussed, it's one of the other. Either you start, the agentic method is you use a lightweight model, you pass in the user's request that was passed into a chatbot, but then your system prompt, we didn't talk about prompt engineering here because there's something called system prompt. I believe for you to even know about agentic workflow, you know about system prompt, user prompt, assistant prompt, and whatnot, right? So your system prompt, you can now tell the agents that, see, while you're responding to this user query, I also want you to respond with how accurate you feel your response is. Now, what you're doing is that you're telling the AI model that, okay, in as much as you're answering, I want to know how sure you are about your answer, right? Now, when you get that response and you see something like 90% accurate, you don't need to go through any other iteration. You can just respond to the user, like pass the stream straight down to the user. Or you can now plug it in that, okay, since this thing is now less than 50%, let's use a higher model with more capabilities, right? And then you can now use a higher model. Now, based on the percentage, if obviously percentage is lower than 60%, okay, the medium model is lower than 40%, you use a high-end model, you understand? So that it can, and then most of this agent has what they call limits, or like the number of times that it can iterate within itself. And once it hits that, it can just respond with the last valid response it got, you understand? So you can configure the whole idea of agentic AI engineering is you can configure it how you want it to behave. You understand? You can attach different sort of tools, skills, whatever at all, as far as it's you, like you're in control over how you want your agents to behave. You understand? So if you want to go through the approach of having a small model that will first of all taking the query or your user's query and then determine the agent is going to pass it to, that's up to you. Or you can go through using the small model, it responds, but it responds with how accurate the response is in terms of percentage before you can now make your own decision of, should I give this user the response or should I pass it into a more advanced model? You understand? It's still left for you. Any approach works.
Let's say we have this model, for instance, and I ask the model to respond with his own percentage based on its response. Won't in as much as I've not tried it before, but won't the model respond by percentage based on its own training data, its own for instance, if it knows, oh, only this part, and it has maybe done the looping through itself and find out, oh, this is my topmost answer, won't it rate itself according to that answer? Oh, with this that I've gotten based on my own, it should be 80% or 90%. While if you push that same response to another model, they might see it as, oh, because of the training data these ones have, that this rating of this one that is saying 80% or 70%, to them is like 20 or 30%.
The issue now is that most of the time AI hallucinates, but when it comes to you giving the system prompt for it to give you how accurate it feels the answer is, it doesn't hallucinate. It will hallucinate the response to you. It can say whatever it wants to say in terms of response to you. Let it be like it has a response, you understand? But when you ask it for it to give you how accurate it feels its answer is, trust me, it's not going to lie. It will tell you as it is because it's based on its training data. So it will tell you, oh, this is 40% accurate. You know, it's left for you to do whatever you want to do. I do not know. Now, this 40% accurate is based on what it knows that it was trained on. Does it make sense? So it's 40% accurate in the answer it gives you. Do you understand? But if it's 100% accurate, obviously a small model telling you it's 100% accurate, which I doubt any model will ever do, to tell you that it's 100% accurate. A larger model might tell you, oh, okay, it's 90% or 70% accurate because it has more training data sets. So I see your bias in your question, but definitely what this does is it removes hallucination, right? Because most of the time AI will hallucinate. Let it just be that it gives you a response. But if you ask it the percentage of accuracy of its response based on the user's question, it will be honest about it. You understand? Especially if you're using an agentic flow, you're not just sending or passing the query direct to the model and back. You understand?
Okay, thank you. I also have another question based on prompt and token optimization. So based on this other discussion now, it means for token and prompt optimization, I just want you to validate what I'm thinking in my head. So for the optimization, we also need two models, right? The first model to send the content, the prompt to, that will optimize it, and the second one to make the request. So that's number one. I just want you to validate that. Then the second thing I also want to ask is, maybe you made mention of having, if you check maybe the token is so amount, you can push it to this model to handle, or push it to this other model to handle the prompt, for instance, that you can tweak it between models. So is there any library that helps us to count the token before we make that decision, or we have to as well make an API call to a model that will count that, return the results, then we can now use it to make our decision to the model to call?
I mean, it depends on the platform you're building on. If you're building on PHP, I believe there are libraries that can help you calculate the tokens that is going to be used, like for the query about to send. Now, for the model, the prompt optimization, you can only trigger, you can do it in a way that if you're using an agentic workflow, you can trigger optimizing the query when the particular input token has exceeded a particular amount. You can do it like that. So it doesn't make sense that I'm calling an additional model in my agentic workflow to optimize a prompt as little as summarizes documents. You understand? It's after the several back and forth with the AI. Okay, the context size has started increasing. Remember, don't forget about context size. Then you can now say, oh, okay, now before I hit this model with additional this thing. Let me optimize these other context messages I have. You understand? So you're not just passing unrelated data that or unrelated requests or prompts to the AI that is not going to affect the results. Now, like I said, there are smaller models, very small, lightweight models that are built specifically for this purpose. Their work is to optimize prompts. So they read, understand your prompt, optimize it, right? So you can pass them the context and they optimize it and give you a summary context that one reduces your input token usage, and two, it gives clearer and more crystal understanding to the whatever model they are going to pass it to, so it understands exactly what you need. You understand? Because most of the time, a lot of people don't know how to um, write prompts. You understand? They just ask AI whatever they ask AI as if they're talking to a human being. And yeah, I understand because that's the whole idea behind AI. But then you also need to understand that when you're now looking at costs, you want to be very, very minimal as possible so you don't spend too much. So you can do it in such a way that, okay, once this token or the context window has exceeded so amount, let everything pass through this particular small model that would optimize the messages that are going to pass into the model. Then you get the optimized message, pass into the model, and that's it. You understand? So does that answer your question?
Yes, very well. Thank you. But I have the last question that I want to ask.
Okay.
So my last question is based on the monitoring. So I read one document on privacy and data privacy and all the rest, whereby they made mention of, for instance, applications not keeping somebody's like a user's prompts and the responses for monitoring, like you discussed. You can log everything to check where the more of your spendings are going and all the rest. So if you are in an environment where data privacy, they don't want your platform to capture any of like any users context, how do you handle your monitoring to know what is happening on the system?
The problem now is a lot of these big boys, they cut corners. Now what is money? How will you know that your data is being used if they do not give you a product that shows your data? So for instance, you register on Google today and you delete your account. Do me and you, do we believe that your account is actually deleted? I don't think your account is deleted. Trust me when I say it. Your access to your account is revoked. You don't have access to your account anymore. But trust me, that account is not going anywhere. Yeah, you might try to register again and they create something new, but your record while you had that account is going to be used internally, like it or not. So you saying that, okay, you cannot use somebody's prompt on your system, something that went through your system. In fact, the privacy policy of OpenAI, where they tell you that if you try to delete your data stays in your system for 30 to 60 days before it's deleted. Now, that 30 to 60 days, what was it doing there? They are using it to fine tune and create the next tier model. You understand? So you cannot give a policy, except you just don't want the data to pass through your system entirely. Then you can say that. But as far as the data is passing through your system, you can optimize. Now, you're not using the person's data for anything, mind you. You're just using it to optimize your system. You're not using the data. You're trying to see what did this person ask for, what did the AI respond, how was this person satisfied, what was the token usage, input, output, is there something I could have done to optimize this cost? That's just what you're doing. You're not actually using the person's data. Does it make any sense?
Yeah, I get you. But I was, I think we will face something like that before, in as much as it's not AI related. But I wanted to know if there is any other way. Maybe you face something like that. They say it's the person's data. They don't want you to have it on your system. Just pass it, process it, and give it back to us. Maybe if there is any way without logging the prompts and the contents to
It's
have
a way that you can just get, but again, if you say you don't want to have the exact data, then probably you can have a system whereby you get a summary of what the person was trying to do. Because there's no way you can optimize the system without knowing, okay, what was this person trying to do in the first place, and why did it take this long? Let's say, for instance, you're trying to see, you're trying to log prompts that the input token exceeded so amount, and try to optimize so it doesn't even get to that point in the first place, so you don't spend much, right? So definitely you're going to see, what did this person try to do? What did the AI respond with? How can I optimize? It is a must that you receive. You don't have to tell the person that, oh, you're doing this, you're using the person's data or whatever. Nobody admits to using anybody's data. Till tomorrow, I don't think OpenAI or Claude or anybody will come and tell you how they got data that they got. Nobody will say it, but they got data. That's all you need to know. It's not your business how they got the data. So that's just the problem. So definitely, to optimize your system, you need to know, what was this person trying to achieve? Why did it take this long? Why did it take this much input token? Why did it take this much output token? What can I do better to ensure it doesn't get to this point for something similar like this in future? It's a must that it has to go through, like somebody has to look at it. Even though nobody agrees to looking at it, but it's a must. It happens.
Okay, thanks so much.
Yeah, you're welcome.
That's all for me.
Okay, that's good. That's amazing. I love all the conversation. Thank you, Mr. Obina. Please, let's drop a favorite emoji for Mr. Obina. Thank you so much. Like, you have actually impacted in us, I must say. So thank you everyone that joined. Thank you very much, Mr. Obina, for such an insightful and practical session. And thank you to everyone who joined and actively participated. We hope you find this section valuable. You have learned something that you're going to put in practice. So it's not just going to be, oh, you learned this thing and you're dusting it. It should be something that you're going to practicalize. So if you still have other questions about this section, you can just drop it in our community, and we have people that are going to respond to you. So make sure you're part of our community. If you're not, please reach out to me, and you're going to be added to our Slack community channel. So thank you so much to everyone that joined. Our bootcamp is actually on, and we have another bootcamp that's coming up. Please, if you're not part of this bootcamp, I will advise that you try as much as you can. Save up money, invest in your career, invest in your future, and sign up for one of these boot camps. For this year, we're going to have a lot of boot camps, so sign up for them. And also, to our workshop is a very vital event that is going to also help your career. So I will also advise that each of these workshops, you don't miss it. So anyone that you miss, peradventure, you have something, you're engaged, you miss them, you can always go to our channel, our YouTube channel, and you're going to see them there, watch them, study them. It's going to help your career. So all the recordings of our office hour, our workshop, are on our YouTube channel. We're going to reach out to you. You can go there, watch them, and if you have questions, you bring it up to our community, and we're going to answer you. So thank you everyone for joining.